Experiment 7. 8086 Basic Connections. The aim of this experiment is to continue the first phase of designing a single-board, 8086-based microcomputer system by making the basic connections of the 8086 microprocessor in minimum mode. To create a new project, click on the New Project tab. In the New Project wizard window, click on the Browse button to specify the path of your project folder. You can select an existing folder to save your project files. In the New Project wizard, specify a name for your project and click Next button to proceed. Keep the project options to their default values. That is, do not create a schematic, do not create a PCB layout, and do not create a firmware project. Finally, click the Finish button to complete the New Project wizard settings. To start a new schematic, click on the Schematic Capture button on the toolbar menu. Click on the Library drop-down menu to pick parts from the library and include them into your schematic design. Search for the 8086 model and add it to your devices list. Place the 8086 model on your schematic and make the basic connections as shown. Connect default connectors to the following 8086 control signals: address latch enable signal, read signal, write signal, memory I/O select signal. Go to the Terminal Selector menu, pick a bus terminal, and place it on your schematic. Connect the bus terminal to the address data pins of the 8086 model. Double-click the bus terminal and label it as shown. Connect 8 default connectors to the bus terminal and label them from AD0 to AD1 as shown. Go to the Graphs menu, select the digital analysis graph, and place it on your schematic. Go to the Generators menu, select the digital clock generator, and place it on your schematic. Connect a default connector to the digital clock generator and label it CLK. Go to the Probes menu, select the voltage probe, and connect one probe to each default connector in your schematic, as shown. To add the signals in your schematic to the digital analysis graph, drag and drop the probes as shown. Double-click the digital graph window and change the stop time property to 400 microseconds. Then uncheck the initial DC solution option. Open the Notepad editor and type the shown assembly code. When you complete typing your code, save your file in the bin directory of the MASM32 assembler as shown. Use the following commands to assemble and link your code as shown. To fix the linking warning message, modify the assembly code as shown. To upload the executable file of your code, double-click the 8086 model. Then, search for the executable file and select it as shown. Next, change the internal memory size of the 8086 model to 100 bytes as shown. Next, double-click the clock generator and change its frequency to 5 MHz. To perform digital signal analysis of your design, select the digital graph window and click the spacebar button to run the simulator. Double-click the title bar of the digital analysis window to expand the waveform graph. Analyzing the waveform graph, we notice the following behavior of the control signals. The address latch enable signal is active in T1 of each bus cycle. The memory I/O signal is always active low, as the instruction is accessing an I/O port rather than a memory location. The read signal is always floating, as the instruction is not reading data from the bus. The write signal is active low from T2 to T4, as the instruction is writing data to the bus. During T1, the address data lines AD0 to AD7 carry the address of the I/O port, which is 22 hexadecimal. In T2 and T3, the address data lines AD0 to AD7 carry data, which is 8-bit binary count.